Okay, let's get started. Can you see my screen?
Yes, sir.
Yes.
Like homework set 1. And I sent out an email, I think about an hour ago or more than an hour ago, that I have posted your credits for the homework on. Have you noticed?
Yes, sir.
Okay, yeah. So I just wrote some comment. For example, there are 5 questions. So each question carry 4 credits. In that way, total credit is 20. So I have given you the credits out of 20. So therefore, most of you did well, although there is some little mistakes in some cases. Let me go over those, and then you match what you wrote in the answer. The first question is, what is the effect of inertia constant H on the stability of a power network? Explain your answer. Therefore, I mean, most of you have written properly. Uh, you see, the higher the inertia constant, the better the stability. That is the thing. This means when a machine has, for example, h equal to 5 seconds versus when a machine has h equal to 2 seconds, definitely when the machine inertia is low, that machine will go upset very fast. And I mean the faster. All voltage, speed, frequency response, everything will be much more oscillating, much more deviating, because that has the less inertia. I mean, same thing in real life, you can see the fact, like when you turn on a ceiling fan, immediately it does not attain its full speed. It takes some time because it has inertia. Similarly, when you turn it off, immediately it does not stop because of its inertia. And then if there is less inertia than the ceiling fan, then that will start spinning very fast. Similarly, even during stopping, it will like spin still faster. That is the meaning. So therefore, uh, stability of the power network means the voltage, frequency, rotor angle, power, everything is maintaining at their rated level or nearby their rated level. So when the inertia is high, the machine is stable. Even though fault happens nearby their generator, but easily the voltage, frequency, speed will not deviate much. There will be some deviation, but not that much. So that is the meaning. The next one, consider that in a hybrid power network consisting of synchronous and induction generators, all machines have the same power rating and inertia. So assume that the both synchronous and induction generator have same rating, for example, 100 MVA, and same inertia constant, for example, 2.5 seconds. So will the machine face the same level of stability owing to a fault in the network? So it is not the same. I mean, the induction generator will deviate much, will be affected much, even though they have the same power rating inertia. Because induction generator is dependent on drawing reactive power from the system, consequently, naturally, it has low lagging power factor. Its voltage goes low. So during fault, it tries to draw much more reactive power from the system. Consequently, the voltage goes fairly low, and accordingly, active power goes very low, and then speed goes very high. So that is coming from the property of the machine. Also, induction generator does not have the AVR and governor system. On the other hand, synchronous generator, even though it may have the same inertia constant, same power rating as to the induction generator, but synchronous generator have AVR and governor. There are some protection or control means. So that's why they will not face the same level of stability due to any fault in the system. The induction generator will be affected more than the synchronous generator. That will be the appropriate answer. Okay, so everybody, can you follow?
Yes, sir.
Amani, can you follow?
Yes, Dr. Ali.
Okay, so Please note down the appropriate answer.
I
Okay,
will.
okay, thanks. Number three, consider a power network has two synchronous generators. The ratings of generators are 100 and 230 MVA. So in case of a fault close to 100 MVA generator or 230 MVA generator, how will the stability level of both generators be affected? Then explain your answer. So the first of all, based on the rating, I mean, it is the common practice. For example, this is 100, this is 230. Definitely 230 MVA generator will have higher inertia constant. Each edge value is higher than the 100. Similarly, if the machine rating increases, then the edge value will increase. It is not, I mean, linearly proportional, but it will increase definitely. That is the common property. So therefore, easily you can guess that if the fault happened nearby the generators, then definitely 100 MVA generator will be affected more. So now, when I say explain your answer, actually you have to consider two cases. There are two generators. The first case is that fault happened nearby generator, 100 MVA generator. That is the first case. So therefore, when the fault will happen nearby 100 MVA generator, definitely because it has less inertia than the other one, definitely system stability will be affected. Might not go fully unstable, but there will be significant amount of uh, voltage, frequency, and speed fluctuation, active power fluctuation. Then the other generator will have also some fluctuation, but less as compared to 100 MVA generator. Then on the second case, assume that the fault happened nearby the 230 MVA generator. Therefore, because the fault is nearby that generator, definitely there will be some stability issue. Active power, voltage, frequency, speed, everything will be changed. But the effect will go on the 100 MVA generator because its inertia is lower than 230 MVA. Even though the fault happens nearby 230 MVA, there will be some effect and significant effect on the 100 MVA generator. That is the difference. So this means that when it is nearby the 100 MVA, definitely that generator will be affected easily, and then some effect will go on the 230 MVA. When it is nearby the 230 MVA, there will be some effect, some stability issue, but then still the much more effect will go on that 100 MVA generator. That is the meaning when I am telling that explain your answer. So therefore, most of you have explained this properly, and that is coming from the fact that 230 MVA has higher inertia constant than 100 MVA generator. Now this one, although some of you have answered properly, appropriately, but still there is, I think, one or two wrong answer. Among the following faults, which one occurs more frequently and which one occurs rarely in a power network? And then can you rank them in terms of voltage stability level? So more frequently happens this one, single line to ground fault. That is the more common thing. And then the rarely occurs, that is the three phase to ground fault, number three. This means, for example, a tree has fallen on a stormy day and then it branches, touches all three phases, and then the root is on the ground. That is the best example. But that is rare. If there is severe storm, then typically that happens. That is the meaning. And can you rank them in terms of voltage stability? So you have to go like most severe to least severe. So therefore, most severe is 3LG, then 3LS, then 2LG, then 2LS, and then the least severe one is 1LG. So in that way, you have to rank. Now you may go from the downward, like you can say least is 1LG, then upward is 2LS, then 2LG, then 3LS, then 3LG. That will work also. Okay, so this one, number 5, does any of the mentioned faults in question 4 have any effects on generators or transformer neutral line? explain your answer. Now, you see the 3LJ and then 3LS, those two are the balanced fault or the symmetrical fault because they equally involved on three phases. All three phases got affected, whatever 3LS and 3LJ. But if it is like 2LS, 2LJ, 1LJ, they are called the unsymmetrical or unbalanced fault. And if there is any unbalanced fault, always there will be some zero sequence current. You remember, at the beginning of the semester, I discussed there is positive sequence, negative sequence, and zero sequence current. So therefore, zero sequence current that flows through the neutral. That is extra current, additional current. So that will flow through the generator, or if the transformer has neutral, then will start flowing through the neutral. Or even if there is any neighboring nearby device that has neutral connected, those neutral current even will flow through those neutral lines of the other devices if they are located nearby. And what will happen? The issue is that typically neutral line is installed based on some withstanding capability, based on some prescribed current capability, heating capability. So once zero sequence current will start flowing, definitely it will be heated up. And if there is more heat, enough heat, even that might be burnt out. So therefore, system will be floating, your generator or transformer, because it does not have neutral. Also, because it is going to other system, neighboring devices, then that device will also be affected. And also, as I told before, if you are barefooted and you are nearby on that generator and transformer, you don't know what happened, and like you are standing on land or soil on grass, but it is little bit, it was a rainy day, there is little water, so it's a good conductor. You might get shock if you are standing nearby. And also, what happens in real practice for the telecommunication line, telephone line, typically they share the common neutral line. They share the same neutral line of the generator or transformer or the power. So it might happen that those zero sequence current start flowing through that line, and that may interfere the telephone communication. For example, you are talking somewhere long distances, you are facing some interference. That could be the cause that some current is flowing through the neutral line. So those are the effect. So therefore, you have answered. So I have given you the full credit. So is everybody fine?
Yes, sir.
Yes. The fact is that when it is 3LS and 3LG fault, it is balanced fault. So balanced fault, then your line will be impacted, generator will be impacted, generator speed, voltage, everything will be impacted. But at least current will not flow through neutral, because even the fault, but still they are maintaining the balance system, symmetrical system. So you understand? So that's why 3LS and during 3LG and 3LS fault, there will not be any zero sequence current flow through the neutral. So that is fine. Those are the most dangerous in terms of severity level. Those are the most dangerous. Most dangerous means connected devices, the line will be impacted, generator itself will be impacted, but at least current will not flow through the neutral. On the other hand, these 2LS, 2LG, 1LG, even though they are less severe, but because they are unbalanced, because of their nature, zero sequence current or additional current will start flowing through the neutral. That is detrimental for the neutral line. Neutral line may be burnt easily because it is not designed to bear or to carry such high current and consequently high temperature. Okay, so I think everybody understood. And then now I am stop sharing. So, and then today we will do some practice question, and then you are ready to go. You are ready for the exam on Tuesday. Uh, can you see my screen? like with some questions?
Yes,
Yes.
Dr. Ali.
Okay. So always and always, like I will ask you questions even in the class and in the exam, you know. So question and question. So that will, in that way, you can learn a lot. So everybody, please, you will note down in your paper. You'll be ready with your pen and paper. Uh, Read the question. In case of a three-phase to ground fault on a transmission line, what are the primary control and protection means which will attempt to maintain the stability of a power network? So the question is, for example, there is three-phase to ground fault. That is the severe storm, and that happened along the transmission line. So definitely in the power network, there are already equipped control means, protection means. So what are those primary control and protection that will attempt to maintain the stability of a power network? I mean, there will be some response, immediate response from those already equipped control means. That is the question. What are definitely in the system you need some auxiliary control. For example, some energy storage device or braking resistor or STATCOM, static var compensator, power factor compensator. You might need the help of auxiliary device. That is different thing. But in the system itself, already there are equipped control means. They will respond at first. So what are those protection and control means? So how would you answer this question? So Venkat, so before you told that you have experience in working in power company or service station, right? So,
Yes.
so what should be the answer based on your experience?
Mm, cir-
So what are the primary control means? I mean the basic.
Circuit breaker.
Yes, yes, that is definitely one right answer. So that is the protection means.
Yeah, relay and circuit breaker combination.
Yeah, so therefore definitely that is, and then that I will treat as the protection means, yes, and then the primary control, which things, I mean, I think one classes or two classes back we are discussing, everybody remember that AVR and governor, automatic voltage regulator and governor control system. But those are the primary control means. So every synchronous machine, they are equipped with those two primary control. One is AVR. What AVR will do? AVR will control the DC field, and that way it can control the terminal voltage. And then the governor will control the fuel input so that it can control the speed and the mechanical power.
Sir,
So
but this is on a transmission line, right?
no, the on a transmission line, but the main thing is that impact will go on the generator itself, right? Yes,
Yeah, yeah, sir.
right. So that is the meaning. The to maintain the stability, because the generator is the main power source that is powering the transmission line. Therefore, whatever, for example, from your generator, the fall point is 1,000 miles away, but still the impact will go on the generator. So therefore, generator terminal voltage, generator speed, frequency, everything will be changed, and that change will go on the transmission line. So you understand, because the main power source is the generator. So therefore, during fault, any change in the reactive power or active power flow, that will basically will originate from the generator. That's why I am talking about the generator. So therefore you have to control at the generator side. And then some auxiliary control means like SBC or STATCOM or energy storage. Those will be along the line somewhere, or voltage regulator, capacitor bank, those will be equipped. And then on the transmission line that you said, that is right, the circuit breaker will open after a certain time, right? That is the protection means. That will protect the line. Yeah. It will disconnect the faulty part. so that the other part remains in good condition, in healthy condition. But the primary controller will protect the generator. It will maintain the stability of the generator. So therefore, you see everybody, you note down. The answer would be primary control will be AVR and governor system, and protection means will be the circuit breaker opening. So circuit breaker will open, and then after a certain time, after a prescribed time period, it will reclose, assuming that the fault has been cleared by then to maintain the continuity of the network. So is everybody fine?
Yes, sir.
Okay, so good. Now read question number 6. An industry has an induction motor that is working properly. Then suddenly a steam turbine is connected to the motor shaft. Will there be any issue with this arrangement? How will the induction motor behave after adding the turbine? Explain your answer. So you go. Has Lakshmi, have you joined? I
No,
think.
sir. Actually, Lakshmi has given you an email. She was telling me.
Oh no, that she did. I think the previous class, day before yesterday, she did. She had some internet issue. Still, that is going
Yeah.
on.
I don't
Oh,
know, sir.
oh, okay. No, day before yesterday, she sent an email that she was facing internet issue. I think she joined and then immediately she left from the class. But today I did not receive any email. Anyway,
Okay.
so Amani, can you try to answer this question?
Yeah, I'm sorry, Sally, I wasn't paying attention to the question.
Okay. The question is, an industry has induction motor working properly, and suddenly you connect a steam turbine to that motor shaft. So induction motor is rotating, mean its shaft is rotating, right? And then
Ye-
at the shaft you connected a steam turbine. This means you added another source. I mean, motor was running with the help of the input power supply. Its shaft was rotating, and then you make an arrangement. You connect a steam turbine that is helping to rotate more faster. Yeah. So therefore, that is the question. Will there be any issue with this arrangement? And how will the induction motor behave after adding the turbine? So will there be any problem, or induction motor will not run, it will stop, or it will start behaving differently? So everybody, could you understand the meaning of the question? So Kamana, what is your guess? What should be the answer?
I think the motor inertia will be affected. Inertia
Yeah,
will be
yeah, definitely. I mean, because we are connecting an additional source, steam turbine, meaning that the shaft will start rotating more faster, right? We are adding external source. So if the shaft start rotating more faster, then what? Then how the induction motor will behave?
It turns into an induction generator, sir.
Yes, exactly. That is the thing. It will start working as a generator, because once you are connecting a steam turbine, meaning that you are making the shaft side or mechanical side more dominating. So therefore, what will happen? Motor shaft speed will be higher than the magnetic field speed of the motor. Consequently, it will start working as a generator, induction generator. That is the impact. So therefore, answer will be no. There will not be any issue with this arrangement. The induction motor will start behaving as a generator, because we are adding a steam turbine. It will increase the shaft speed, and the shaft speed will be larger than the magnetic field speed. So instead of taking active power from the line, it will start providing or delivering the active power to the network, to the system. So do you understand, everybody?
Yes,
Yes, sir.
Surali.
Yes. That's great. Thanks. Okay, then question number 7. Consider a power network has assigned line impedances. There is a power network and it has the line impedance. Line impedance means it has R value, it has L value. That is the meaning. So if the line reactance increases, will there be any effect on system stability? Explain your answer. So Sindhuja, are you online?
Yes, Dr. Ali.
Yes, you try to answer this one. What should be the answer? The power network line impedance means, as I said, it has resistance. I mean, in real practice, every line has resistance and some reactance. I mean, L value, inductance value. And then I said, if the line reactance increases, for example, your reactance value was 5 ohm, and then you increased it, 7 ohm, 8 ohm, 10 ohm or more, you increased. So will that increase of line reactance have any effect on system stability? So therefore line reactance increase, as everybody see, line reactance X increase mean what will increase? What it will increase?
So the reactive power will be more. It will
Yes,
draw more reactive power.
Exactly. So
And
and then what is the consequence of that?
Voltage unbalance.
As voltage drop, there will be
Voltage
more,
drop, and yeah, consequently.
yes, and then power factor will be low.
Exactly.
Because increasing this means it will increase the Q, reactive power. That's the correct answer. And consequently, there will be voltage drop, and then there will be low power factor, meaning that the voltage will go down. So therefore, when I said, will there be an effect of stability? Yes, there will be voltage stability issue. Definitely there will be voltage stability issue. So that will be the answer. I think everybody get it, right? Yeah. Now read number 8. In case of a permanent fault on the transmission line, the circuit breakers are reopened after reclosing. What will happen if you attempt to reclose the breakers repeatedly? So the meaning of this question, I have introduced a term like permanent fault. What does that mean? So permanent fault on the transmission line, the circuit breakers are reopened after reclosing. What will happen if you attempt to reclose the breakers repeatedly? So therefore, let me take you to the whiteboard to explain the context of that question. So for example, these are the lines are going on, and this is, for example, circuit breaker. This is circuit breaker number 1, and then right side there is another circuit breaker. This is circuit breaker number 2, and then the circuit breaker basically they work like as a switch. Therefore, normal condition, like the switch is closed. Normal condition, the switch is closed. That is the meaning. So in that way, like current is flowing. Now, for example, the fault happened. Somewhere fault happened. For example, here the fault happened. And that fault, the question says, statement says, it's a permanent fault. So the difference between temporary fault and permanent fault is the duration. How long is it? If the fault duration is only few seconds, then you will call it the temporary fault. For example, although I drew just one line, but in real practice, there is 3-phase line, like A phase, B phase, C phase. Now, for example, the lines are running properly. As an engineer, you are working, taking a ladder. For example, you have a ladder, and with the ladder, you are working something on the line. You are fixing something. And then you yourself made a mistake. You just caused a short circuit. But then immediately you realize, no, I caused a short circuit. I'm doing something wrong. And then immediately you remove that one. That is called the temporary fault. Or for example, because these are the, the lines. So frequently the birds fly. So suddenly a bird created a short circuit, and then the bird got shocked, and then bird flew away. That caused temporary, short circuit. That is the example of temporary fault. Now, the example of permanent fault is not that bird or the engineer. For example, there has been a storm, and then because of that storm, for example, three-phase line, and there was a tree, and then tree is, touching all three phases, short-circuited, and then this is the root of the tree, and then other end also making like that. So this is the, the best example of that 3LG fault, and it is the permanent fault. Why it is permanent fault? Because you see the branches of the tree is touching or making contact with all three phases for a long time. Like it got stuck, you see, or it may not be all three phases, maybe just two phases, or even it could be on single phase only. Like this is the situation. So therefore, the branches got stuck. It got twisted with the cables. So therefore, what will happen? Unless the crewman goes, unless you, call the technician or the crewman from MLGW, the fault is going on. Fault is going on. That is the example of permanent fault. So now, by that, what I mean, that during any fault, whether it is temporary fault or this type of permanent fault, what will happen? You see, the first action is your circuit breaker will open. Circuit breaker will open. Switch will open. Switch will open means then this portion is getting disconnected. This is the faulty portion. This faulty portion is getting disconnected from the rest of the system. That is the meaning. Now, if it is, everybody say, if it is temporary fault, then what will happen? Circuit breaker open, and then because it was engineered, someone was working and realized that no, I was making short, or a bird was suddenly made short circuit and bird again flew away after getting shot. So fault removed. So if the fault removed, then the common practice is to close the breaker again. To close that breaker again. It is called the reclosing. So therefore, first it opened and then again it reclosed. That is called reclosing. Although there is some standard timing, first circuit breaker opening, it takes 5 cycles. 5 cycles of the waveform. 5 cycles. And then the reclosing time is kind of 45 cycles. This means you first fault happened, your protective relay system understood that there is fault, and then that opened the breaker. That takes 5 cycle of the waveform. Here there was voltage and current. This is like 1 cycle. So in that way, like 5 cycles. So if it is 60 Hertz system, then time period of 1 cycle is 1 over 60. You will be getting about 16 millisecond. 16.67. You calculate, you will be getting this millisecond. So in that way, 5 cycle means this multiplied by 5. So kind of 0.083 second. After that time, this breaker will open. And then again, there is a standard practice. You have to wait 45 cycles. Circuit breakers are designed accordingly. It is automated. It is not manual, automated. The minimum is like at least at the minimum, you have to wait 30 cycles. This means 30 multiplied by that millisecond. That is the time waiting. And then what happens? Circuit breaker will reclose. Why the circuit breaker will reclose? To maintain the continuity. Because we are assuming that the fault has disappeared. Fault has been cleared. It was temporary fault. And then the system runs fine, stability maintained. But what I am talking by that question, that no, I reclose the breaker because it is auto program. After 30 or 45 cycle, it reclosed, but still fault is going on. So therefore, what is your guess? What will happen next? So Manoj, what will happen next? I close the breaker, reclose the breaker after the prescribed time because it is auto program, but still fault is going on. The tree has touched, it twisted, and MLGW engineer is not coming. It has been like several minutes or even it has been 1 hour, nobody is coming. So then what will happen?
Then again, the circuit breaker will go close and reclose again and again.
Exactly. This means because it is pre-programmed, once it is closed, then again it understood the protective relay, there is fault. Then again, because pre-programmed, again it will take another 5 cycle, it will open. And then again, after some time, it will try to attempt to close. So therefore, what is the meaning of that is time trying to close. So let me explain you. So what is the issue of reclosing? The issue is that think about for example, the I current is normal current. Let's say 10 ampere normal current was flowing. And then the short circuit means, you see, your current is going very high. It was 10 ampere initially, but it is going very high. In that way it is going. And then you thought that, okay, fault has disappeared. I mean, and the protective relay thought fault has disappeared. It attempted closing. But for example, still the current is high because the fault is going on. So next attempt, what will happen? Because you closed, current may go much more higher. And then again, the third attempt, it may go much more higher. So what is the issue with that? In one hand, it's a huge burden on these lines. These lines may fail, but even these circuit breakers had some withstanding capability. They may not tolerate this amount of high and high current. You understand? Therefore, these circuit breakers even might be damaged. So that's why it is not, usual practice that, okay, fault is going on, which is called permanent fault, and you will just close, reclose, close, reclose. It is not safe. The circuit breaker might be damaged. That's why, and like in MLGW system, like I have asked them, they attempt 3 times, like first reclosing and then failed, again open, again close, then failed, again. So they go 3 times. But in some other places in USA, they go 2 times. I was living in Japan, then they go just 1 attempt. After 1 attempt, they understand it is the permanent fault, existence of permanent fault. So to save the circuit breaker, then they even don't attempt twice, only 1 attempt. And then they distinguish whether it is permanent fault or temporary fault, just by looking the nature of the current and some other parameters. So everybody, could you understand what I am telling?
Yes, sir.
Yes. So now go back to that question. Now go back to the question. Read that question now. In case of a permanent fault on the transmission line, the circuit breakers are reopened after reclosing because it will reopen. What will happen if you attempt to reclose the breakers repeatedly? So therefore you understand the consequence. You might say the circuit breaker itself might fail, might be broken, might be damaged. And of course, because of reclosing, the connected system, connected device will also be affected significantly. That's why it is not suggested to attempt multiple times. I directly asked the MLGW that how you do, what you do. They said that our system is auto-programmed 3 times it does. After the 4th time, it will not go. Then they get alert message that there has been some fault. And then by the alert message, they can guess the distance and then they send the crewman or power line. Okay, something happened. Is it tree fallen or some other issue? Something happened. And then they need to go physically, and then when they remove the fault, they clear the fault, and then again the systems comes back. That is the meaning of this question. Everybody note down in your note.
Yes, Dr. Ali.
Okay, thank you.
Dr. Ali, I have a question, please.
Yes, come on. And sorry, Amani.
So I would like to ask about the case in overseas. So I remember when I was in my hometown, if we have outage, we used to go directly to the circuit breaker and reopen try to reclose the circuit breaker.
Yes.
So that will damage the circuit breaker by itself, or also that will also make damage for the appliance.
So yes, so the impact might go, that is the thing I told, the impact might go on the appliances, all connected devices, if you attempt multiple times.
Oh, but I thought if the breaker is broke, so that also will make it safe for the appliance, because the circuit will be open. So how that will damage the appliance?
So I understand. So the circuit breaker damaged mean like line automatically got disconnected, right?
Mhm.
Yes.
Yeah.
But you see, if you think only from the viewpoint of your home, then typically what happens in our home, which thing is circuit breaker? The fuse, right? The very thin wire. So therefore easily you can fix that. But would you expect along the line that circuit breaker got damaged? Because if it's a huge expensive system, there is a protective relay and together control. Therefore, it is not the expectation that circuit breaker, I will damage the circuit breaker and so that the line got disconnected. I mean the device protection, you see. I mean, if unfortunately circuit breaker got damaged, then automatically the line got disconnected. But that you should not desire that, and you should not hope that let the breaker damage. So we are talking that we want to save the breaker, because if along the line the circuit breaker got damaged, then physically again you have to install. It's a matter of some time. It will take long time to replace the broken one, then replace with the new one.
Yes, because overseas we used to do that manually. That's why I'm asking this question. We can close the circuit manually.
Yeah. So yeah, I understand. Yeah. So
Thank you.
I mean, at home easily you can fix that with thinner, and very frequently it got cut. But along the line, if the circuit breakers got burnt or damaged, then that is like incurring cost.
Yes.
Yeah, that is problematic. So that's why I said that in Japan, I have noticed they have programmed such a way, after on reclosing, immediately their system will understand, okay, there has been something wrong. It is not the temporary fault, permanent fault. Whatever the, is it tree or other reason, then they don't attempt the second time. So what they do, they immediately send the engineer, and if necessary, they shut down the power in that area, and then they take quick action. Okay, so question number 9 is, although harmonics can be generated at the steady state condition of a power network, but can it affect the system stability? You see, we're talking about the harmonics, and I said the harmonics can be generated at the steady state. Steady state means there is no fault, no storm, no thundering, no lightning issue, nothing happened. Your system is running well, it looks like. But then you found that there is significant amount of harmonics. For example, through oscilloscope, you are looking the power, voltage, and current profile. And you are noticing they are not sinusoidal. There is significant amount of harmonics. But no fault, no short circuit, nothing happened. So do you think that harmonics might affect the stability? That's the question. So who likes to answer this question?
Yes, I think
Yes.
affect this
So it will affect. So then explain the how and why.
because harmonics means like multiple of the fundamental frequency. So you'll have like multiple frequency coming out. So
Exactly, and then and that is absolutely right. And what will do that multiple or the higher order frequency? What parameter will be affected?
the frequency of the grid.
No, the frequency of the grid will affect what? If you think about the impedances, it will impact the resistance or it will impact the reactance.
Reactance part.
Exactly. So therefore, everybody see, as you know, the harmonics means that multitude of or multiple of fundamental frequency, not 60 hertz, like 120 hertz, 180 hertz, or even it could be higher. So then resistance is independent of frequency, you know. But think about the reactance X. What is X? 2 pi FL. like XL, inductive reactance, 2 pi FL. So therefore, inductive reactance is related to frequency. Therefore, your reactance is getting high. Then that is taking you back to question number 7. Once again, you read question number 7. If the line reactance increase. So in this case, harmonic will increase your line reactance. And then we discussed question number 7. Remaining portion is the same answer. So therefore, answer will be the yes, it will affect the system stability because harmonic will introduce higher order frequency, and that will increase the reactance. And that reactance will increase the reactive part, and ultimately the voltage, there will be significant voltage drop and the low power factor, and there will be voltage stability. Therefore, I mean, this is pretty interesting, question number 9, that a system was running at steady state condition, but then you are measuring voltage at any point, for example, at your home or in industry, you are noticing the voltage is significantly low. Then what is the cause? Like you are noticing, no, there is not any short circuit. No, like it's a good sunny day, there is no storm, nothing happened when you did not get any report. So then you have to assume that some of your loads, maybe the industrial load or at your home, some nonlinear load, that is creating more harmonics somehow. And that is causing that problem. So meaning that your stability is getting affected. Everybody, do you get me?
Yes,
Yes, sir.
Dr. Ali.
Yes, good. Please you all note down these questions. Then question number 10, right? Consider the voltage at all buses in a power network are not within acceptable limits. So meaning that definitely this is the case of voltage stability issue. So all buses voltage are not within acceptable limit, voltage stability issue. Which of the following strategies might provide better bus voltage control? So because there is voltage stability issue, so therefore now you need to put some control means. You have to control the bus voltage. So like I have written 3 things: parallel capacitor, parallel resistor, parallel inductor. Which things might provide better bus voltage control? And explain your answer. So therefore, who likes to answer this one?
I think it would be a parallel capacitor.
Yes, definitely. So why? What is the issue with resistor and inductor?
Because the parallel capacitor would be able to supply the reactive power, which
Yes.
I mean,
Yes, capacity. And what does resistor will do?
it will just draw more power if we.
Right, it will just consume more power, right? Resistor function is only one. It is happy with the consumption only. It cannot do anything. It cannot contribute to anything. It is happy with the power consumption. And what does the inductor will do? What it will cause?
So I think it doesn't give the power factor correction or reactive
Yeah,
power
I mean,
support.
yes, both are the reactive component, the capacitor or inductor, but it will provide more low lagging power factor. Inductor, because in case of inductor, that current lags the voltage. So if you connect inductor, then it will provide much more reactive power. There will be more reactive power loss. But the capacitor, it will work against the inductor. If the network has like more reactance, like question number 9 or question number 7, more reactance, then capacitor will work against it. It will provide the anti-reactive power. In that way, it can improve the power factor. So therefore, the answer is you have to use the parallel capacitor because it will provide the capacitive reactive power that will compensate the inductive reactive power available in the system, and that will improve the power factor. I mean, it will reduce the magnitude of reactive power that comes from the inductance or inductor. It will work against the inductive reactive power. That is the answer. Okay, so fine then. I think we have only few more questions. Then for today, you are ready to go. Only 3 more questions. Now, these 3 questions are with regard to this figure. Everybody see. Assume you have 2 measured signals, namely generator terminal voltage and rotor speed. And to improve the voltage stability, you are planning to design a controller to be installed at a suitable bus in the power network shown in figure 1. For example, in this figure, IEEE 9 bus, before we discussed, this system has voltage stability problem. And to handle that, to tackle that voltage stability, you are planning to design a controller. And you want to put that controller at an appropriate bus. For example, number 5 or number 6. You have decided I will be putting a control means. Now you have your controller needs some signal, and you have 2 signal in hand. One is generator terminal voltage, you know this terminal voltage, and also you know the speed, generator speed. Now would you choose voltage signal or rotor signal as the controller input? Explain your answer. So therefore, who will answer this question? Amani?
Yes, Dr. Ali.
So
Um,
we want to design a controller at any
Mhm.
bus. For example, bus number 5, we want to put a controller to improve the voltage stability. That is your goal.
Mhm.
Now you have a controller, and that controller requires some signal. You have 2 signal. One is generator terminal voltage information and rotor speed information. Now, to make the simplicity of the controller, just use only one input, not both input. Either choose voltage or choose the speed. So therefore, which one would you prefer to maintain the voltage stability? It is voltage signal or rotor speed signal?
Rotor signal or rotor speed signal.
Yes. So you are maintaining the voltage stability. So,
Mhm.
so definitely you will choose the voltage signal, right? Yes, because you want to maintain the voltage. So therefore, appropriate signal will be the voltage signal. Now, you might argue that okay, during any fault, during voltage stability, some impact will go on the generator shaft. So I might choose rotor signal as well. So the answer is yes. I mean, you might choose. It will help you, but it will not help you properly. It will help somewhat. System stability will come back somewhat, but not fully. Still oscillation will continue. So therefore, you have
I
to,
thought I was thinking about rotor speed signal. So can you please explain why it's not rotor speed signal, Dr. Ali?
because it is the issue with the, you see the second line, the middle of the third line,
Mhm.
and to improve the voltage stability. Your goal is to improve voltage. So voltage
Yes,
stability
that's
at
why.
that,
Yeah.
yes, at that time your preference will be, mode of dominance will be voltage. When it is transient stability control, rotor angle stability control, at that time your importance will be on the speed. So therefore,
Yes.
because voltage stability, so you have to choose voltage signal. Now,
I
as I
thought I
said,
have to. I'm sorry. Go ahead. I'm sorry for
no, sorry,
interrupting
no,
you.
you go ahead, go ahead.
I thought I will. I was thinking about rotor speed because I think maybe if I control the speed of the rotor, that will help me to control the voltage.
So you see the voltage signal control means, again, let go back. Can you remember that AVR model? What is the input on the AVR
Mhm.
model? That is the voltage.
Mhm.
And rotor speed is the input to the what? Governor system. Therefore, the rotor is, if you use the rotor speed, it will control the governor or the shaft system. But still, at the bus voltage may not come back to the original position.
Mhm.
I mean, all are interrelated. Something interrelated. I mean, if you use
Yeah.
rotor speed, it will help something, but not fully. You see, so therefore, I mean, you remember that in the past I gave an example of some medicine. For example, the Tylenol. So what is the function of Tylenol or the Motrin? It can help you, it can control you a little bit the fever if you have the heat on your body. But if you have really need the, the antibiotic medicine, that will not help. You need to go to doctor. Doctor needs to give prescription. Unless you take that prescription, like your fever is not going away. Always you feeling some heat because you have some infection or other issue in your body. So that's why when it is voltage signal, if you use the rotary speed as the input, it will work as a Tylenol or the Motrin or the Advil. I mean, it will help you just at the preliminary level. It cannot fully cure you.
Yes, yes.
On the other hand, the same thing, if the problem is transient stability, the problem is on the shaft, you have to face that. And voltage is not the problem. Then you choose the rotor signal. At that time, if you choose voltage, then voltage will work as your, again, the Tylenol. That is not the proper antibiotic. So it depends on the mode of dominance. You need the appropriate antibiotic. Normal thing will help you a little bit. Everybody, could you follow me? What I'm saying?
Yes, Dr. Ali.
Yeah. Okay. The next question. Consider the stator current waveform of the synchronous generators in figure 1 have distortion. So in this figure, there are two generators, G1 and J2, and they have the stator current, I mean, the actual current that is produced and going to the network. So there is some distortion. So then is there any consequence of that distortion on the generator's stability? Because like this class is dedicated to stability, so everything is related to stability. So I am bringing all those possible scenarios that we need to understand, and we have to put control means. Now, this system is running. Everybody look, this system is running properly. But then again, you are looking, you are measuring, you have an oscilloscope here and here. You are looking the signals. You are looking the stator current waveform. And then you notice that there is significant amount of distortion. It is not pure sinusoidal waveform here. Then could there be any consequence of that distortion on the generator stability?
Yeah, I think it will cause some harmonics.
Exactly. So distortion is again nothing but the harmonics, right? Yeah. Therefore, if you have distortion here, meaning that you need to the analyzer, you have to apply the Fourier technique, Fourier series, to decompose, to find out the useful component, which is fundamental frequency component, and then the rest of the harmonic component. So if you use frequency analyzer here, and if you can uh, find out, distinguish between the fundamental and then higher frequency, and then those higher frequency, those will have impact. Because those higher frequency, again, they will cause higher reactance and higher reactive power. And again, there will be voltage stability. Therefore, this distortion problem, that will also cause, like for example, your prescribed voltage here is 11 kV, and then you are measuring the voltage and you are getting fairly low value. Then you are not getting the answer. It looks like, no, there is no short circuit, no open circuit, nothing happened. Network is, but then still I am getting low value. What is the cause? That distortion is the cause. So it is not just like you are looking on the oscilloscope, there is distortion. That is ultimately affecting the frequency. It has multiple higher order harmonics, and that harmonic is changing your reactance throughout the network. And that is exposed as a reactive power loss. And because of that reactive power, you are getting the low voltage here. I mean, unseen problem. You are not looking anything, but then still you are getting low voltage. That can be the reason, the distortion. And then, of course, the impact is going on the stability. Okay, so the last question for today. During a network fault, although the grid voltage goes low, So you all know the common tradition or common practice when there is any fault and a short circuit, then the voltage will go low. But then what is the meaning of short circuit? What is the meaning of the fault? Your current will go high, right? But the line current increases. Therefore, while current increases and voltage decreases, this means one factor decrease and other factor increased. So therefore, it is the expectation that real power should not change from its steady state value. Then why is it always observed from simulations and experiments that the real power goes low? So, I mean, let me take for a minute that.
May I try?
Yes, here.
Oh, thank you. I think that's because the law of power factor.
That is partially true. But the thing is that it depends on the voltage goes low means voltage goes very low, and then current increases means current increases somewhat. So therefore, compared to the current increase, decrease of the voltage is much more significant. I mean, one thing increasing, other thing decreasing, but it is not like linearly proportional. It is not like voltage will go down 5 times and then current will go up 5 times. It is not. Current will increase somewhat, but voltage will go maybe 10 times more than that. So therefore, voltage going down, that is much more dominating. Therefore, if you multiply that voltage and the current increase, but voltage goes low means very, very, very low. Only, for example, 5 volt or close to 0 volt. That makes your active power very, very low. That is the thing. So if it is like 5 time increase, 5 time decrease, then multiplication would remain the same. But that is not linearly proportional. So that's why it happens. So therefore, answer would be that although current increases, but voltage goes significantly low. And the increase of current is not equivalent or equal or not proportional to the decrease of the voltage. Voltage really go very, very low. And that cause the power goes low. That is the answer. So is everybody fine?
Dr. Ali, can you please repeat the answer?
So therefore, just a moment. Let me, I was trying to take that whiteboard. Let me erase this thing. Okay, so I mean, think about that equation that I frequently explain, that phi Pm minus P, right? That is that electrical power, and then we say this is swing equation. In ideal condition, that is 0. Now, for example, there was line and then some short circuit happened here. So short circuit happened means current increased. Your current value increased something, but if you look that voltage during the short circuit, then it was, for example, initial voltage that might go very low. Even it might go close to 0. That is the impact of the fault. So voltage will be significantly low. So now here you might notice that the power is going very close to 0. So that is the thing I am asking, that we say, okay, during fault current increases, voltage decreases. So therefore, because current increase, voltage decrease, so therefore this should not change. But then it goes close to 0. Why that goes close to 0? That is the question. So therefore answer is, although current increases, but voltage decreases much more. It is much more dominating, much more significant. The amount of voltage decrease is much more higher as compared to the amount of increase of the current. And that's why, because power is the multiplication of voltage and current, ultimate results goes very low. That is the answer. Like for example, for example, you have a certain sickness or illness or certain disease. And then it was too late to go to the doctor. Like, for example, you have that problem 1 year, 2 years back, and at least you went to a doctor, and then doctor gave you some medicine, but it did not, it could not recover. Like, still that is going on. So then what you say, that although you went to doctor, but then by then already the disease has spread in your body or something happened. That's why it did not help you. So meaning that that is the more dominating as compared to doctor's action. Although doctor gave medicine, the same meaning. Although current is going high because of the fault, but compared to current increase, voltage decrease is much more significant. So that's why your power is going very, very low. So that is the answer for this one. This one. So we read once again. During a network fault, although the grid voltage goes low and but the line current increases, therefore while current increase, voltage decrease, the real power should not change from its steady state value. Then why is it always observed from simulation and real experiments that the real power goes very low? So explain your answer. So because voltage goes very, very low, as compared to increase of current, decrease of voltage is much more higher and higher. So the multiplication takes you much more low and the low value. So everybody, do you understand?
Yes, Dr.
Yeah. And then the other thing is that once voltage goes very, very low, then your torque value goes very, very low, because torque is proportionate to voltage square. I think I should write that on. That will clarify you much more. I should write. So that phi, actually, what is that phi? You know that phi means that electrical torque multiplied by the speed, right? That you have used in problem solving. So because and then let me write that torque is proportionate to this voltage squared. So therefore everybody say, when voltage goes low, can you guess? That torque goes very, very low. And then because the active power is multiplication of torque and speed, whatever your speed is, this goes close to zero. That is the reason. So therefore it is not like that, okay, current increase, my voltage decrease, so the multiplication will compromised. It's a trade-off. It will not happen. Like power goes low, really, because of these reasons. Voltage decrease is much more dominating. That cause torque goes low, and according to the equation, definitely power goes low. I think everybody understood, right? Yeah. Okay, so there is no more questions today. So that's all. So therefore, for the syllabus, you will be start looking from chapter 1, sorry, the class 1 to until today. I think it is class number 9, probably. I think we already discussed in last class. So therefore, in the exam, as I said, you might expect 7 to 8 questions. There will be some short questions like that. The answer will not be too long. You don't need to write much things like yes and no, and then explain the answer somewhat. If you have time, then you elaborate. That is most welcome. But then there will be some numerical problem as well. So therefore, it's a mixture, some short question and some numerical problem. So is everybody fine?
Yes, sir.
Okay. So then I'm stop. So